Welcome to another demo. It took me a while to get to this point because all I really accomplished was jumping, and I think I demonstrated running previously. And you can run and jump on a block. You can let yourself slip off the block. Or run and jump off the block. You can do a walking jump onto the smaller block. The problem though that I was having was, here you can see a velocity graph that I set up for myself so I could do an analysis of the velocity as things were happening. The problem I was having was up against the wall, I was getting uneven, very staggered movement. You can see it's very smooth now, but what I was doing was some complicated, I attempted to get fancy with the primary and lateral axes and how I'm moving, and accelerate in the direction I'm pushing and decelerate more slowly in the direction that I'm not pushing. And all that did was complicate how things happen when I was up against a wall. Because also when I collide, I add some padding and I back up the collision just to make sure that the object isn't truly fully touching the surface. That way I can make sure collisions will still actually happen and the sphere won't poke through the wall. I am doing a containment correction to make sure that it's still inside the room, but I want to be able to detect collisions as they actually happen instead of just correcting the position. So all of that in combination, what it was causing was in this tiny minute movement like this, it was happening in very staggered fashion. So I changed the movement acceleration to just be a simple interpolation between where am I currently, which direction am I currently moving in and which direction am I trying to move in, and just interpolate between those two and make the current velocity equal the velocity of where I'm pushing. And that was simple enough, and instead of backing up the collision to give myself the padding, I push the object out by the surface normal of the collision itself, because if you back something up, that takes away some of its movement forward. And that was, I think, also contributing to the staggered movement along the wall. So when you're working with floating point numbers and you're possibly dealing with very tiny numbers, it's best to just take the simplest approach possible and try not to do anything too fancy. Otherwise you can just chase the algorithm in circles figuring out where the problem is. And the fancier you try to get with your formulas, the more difficult you're going to make things for yourself. Maybe if I had applied better science, I would have been able to do things the way I wanted and got the result I wanted, but the code was just getting more and more complicated, and I just wanted to move on to the next thing. So that's what the current status is, and next up I'm going to try to get overhangs and get it to the point where you have to crouch to walk under an overhang, and to be able to walk up a sloped surface and slip down a steep one. So that'll be the next big project, and I'll upload another video when that happens. Thanks for watching.